Today we're going to populate the MCU PCB board, and if we start on the top left corner, we've got some surface mount voltage regulators. That's 5 volt, and then that one's 3.3. It's important to get the right component for the 3.3 because there's several D2 pack components and some of them aren't wired rightly. If we look over here, we've got an option for CAN bus. We're not going to implement this today. And down here we have some regular 0603 LEDs. We've got an SBUS circuit, and here, look, we have some voltage dividers, which is really useful, and they use 0603 resistors there. And a buzzer. This is quite useful for commissioning the system and just generally debugging, as are the LEDs. I suppose the buzzer and LEDs are optional, but I find them incredibly useful. Just whilst we're here, this PCB is made by PCBWay. I've got another one here which is made by one of their competitors, and it's actually got a fault on it here, tiny little fault. You can hardly see it, but this pin is filled with solder, so this whole PCB arrived faulty. I still used it because I managed to snap off one of the legs on the connectors, but just shows you get what you pay for it. I mean, these are cheaper, but if you want good quality, reliable quality, then pay a little bit more. Go for PCBWay and get this fantastic stencil here. Let's put it the right way around. Get that lined up there. So we'll use a microscope to line this up. Make sure that all the surface mount components are exactly right, and then paste the solder paste over that. That all looks pretty much perfect. Before we get too carried away, we need to clean the stencil. If that goes hard on that stencil, it's an absolute nightmare. So I'm going to get some isopropyl and give that a quick wash. These next ones here, that's 10K and 0K. Definitely don't want to get those mixed up. So let's do them. Unfortunately, this one's got a big fat 0 on it, so makes it really easy to identify. Can't really read the writing on that one without a microscope. Now I'm going to have a go at the LEDs. So these LEDs have got tiny little green marks on them, and the green always indicates the cathode. A couple of 0.1 microfarad capacitors on the voltage regulators. Okay, larger components. So I'm going to put the buzzer on. Just make sure the buzzer's the right way around. It's got a positive here, but you can use a multimeter to test the rotation of the buzzer. So on this, the writing on the PCB is the same orientation as the writing on the buzzer. There he goes. So I've already tested that and made sure that that's correct. Here's the 5-volt regulator. Definitely don't want to get these two mixed up. And here's the 3.3 one. Right, so you probably noticed something a little bit strange here, I don't know. This one's got a middle pin that's not connected to the PCB. It really doesn't matter because the ground here at the back is the most important part there, and it just the pad tab connects to that pin anyway, so that pin doesn't really do anything, not anything extra. I mean. So we've got our capacitors. So we've got a black crescent which indicates ground. Right. So these capacitors get a nice stable voltage supply to the voltage regulators. I think everything's ready to put it into the reflow oven. So I've checked all the surface mount components with magnifying glass and everything looks okay. All the resistors are good. The LEDs are good and on the right way around. So I can start putting the through hole components on, and the first one is the ZX450 NPN transistor here, which is used for inverting the SBUS signal. I could just as easily as used a service pack component for this one. I just didn't get around to changing it. It's no big effort to put a through hole on it though. I mean, there's all these other through hole connections to be made, so I don't think that's going to make any difference to the time. So there he is. The orientation is given by the graphics on the PCB, so it's kind of impossible to get it wrong. Just flip it over and solder it up. Okay, we have to be careful now to do everything in the right order, but next thing to solder onto the board is these male-female headers, and you need to bear in mind that this board here is orientated underneath like that. If you look at the top, you've got reset, Ethernet, USB and user which corresponds to blue is using MCU1 is the Ethernet and the black is reset. Just check that again. Yeah, so that's the orientation. So to achieve that, we have 4 rows of male-female pins. So let's start with, I'm just going to solder in the ends and then make sure that the MCU is going to slide it on. Okay, so it's possible to get these headers slightly at the right angle, wrong angle, so it makes it really difficult. See, this one here is already splayed, so we're going to adjust that after it's been soldered on at each end. Make sure that this board engages into it properly without damaging anything. So we don't want to force the MCU onto the board. That's what's happened before with not with these MCUs but others, because of the huge sides of these chips. I actually managed to crack the chip or get it dislodged from the PCB before, a few years ago, not recently. There we go. So going to solder a little bit and check a lot. So look at that. It's totally wrong. That's like just what we're talking about really, but it's not too late to just that little bit of adjustment. I can feel it with my fingers underneath. There she goes. There we are. I can feel it sort of coming right with my fingers underneath it. This one's better, but just do that as well. Yeah, that's great. That's still splayed open. Way. That's better. Still this end's right. That's good. So I can very tentatively offer this up. I'm not going to try and put it in because it's not soldered in properly. So I think if I did try to force that on now, when I took it out, it's just likely to rip out all the pins because they're not soldered in, which would be an absolute disaster. But you can see I can feel that it's in roughly the right position. It's great. So I can very tentatively start soldering some of the other pins, maybe some in the middle, and then check it again. Keep checking. But do not try to attach this board onto these headers until they're all soldered up. So I think it took about 5 minutes to solder this up, and I'm ready to have a go at pressing in one of these MCUs. I'm actually going to initially use a broken one, so this is a broken one. I don't know how I broke it, but yeah, the other thing is copious quantities of WD-40 are required. Just do not spare the WD. This makes a massive difference. Makes it also makes a nice mess, but to get these things on can be difficult. With WD-40 makes a huge difference. So again, pushing it on, just push it on gradually without creating stress on this chip. So we don't want it to go banana shaped. Just nice and easy, as you guys. I'm not having to put a lot of pressure on there. So I'm checking that it's seated properly. Yes, it is. And now, critically, I want to take it off again. Again, I do not want to stress the whole board by trying to lift it from this end, or lift it from this end. Guaranteed you'd crack the chip. So we're just going to very gingerly prise it off. And even though this board is broken, it's still a good idea to practice taking it off in a sensible manner. So create a bit of a gap there. This screwdriver head is quite useful for very gently prising that side off. I'm not taking it all the way, just a little bit. Do the same here, just work along nice and gently. It's not going to cause any stress on that chip by doing this. And the more times that this is done, the easier it gets, because the WD-40 gets into anything. Anyway, it came off really easily. So the board's now covered in WD-40, so it'd be a good idea to clean that off before the next stage. And I think the next stage would be to put in some of these Wago connectors here. And then there's like a huge number of them. I think it's like 350 individual connectors or something like that. They should go on there. The great thing about these Wago connectors here is that you can take the ends off and bolt them together. So you can bolt the whole section here together by removing this end there. There you are. Just keep on adding them until the required required length is cut, and solder them all together in one lot. Pretty neat system. So I've prepared these orange Wago connectors. These are the right length, so I can slot them into place. A little bit fiddly. Come on. So I'm going to get them all into position. Obviously the wire openings have to be facing outwards, so also wouldn't get a wire in that gap there, I hope. So that's all pretty neat. Now, in the past I found that it's quite easy to get these wonky, so we're going to apply the same technique as we used before when we soldered these headers on. That's just to solder the ends, check that they're not wonky, or if they are, you can realign them, and then keep on checking as the headers are terminal blocks, I mean, soldered up. So just going to do the ends first on each row. Here's the first row. So I'm not too worried whether they're out of position at this stage. What would be a disaster is to solder all the connectors up and then turn it over and find, oh dear, it's not in the right place, it's not seated properly. I've done this quite a few times. I've done the same mistake quite a few times. So hopefully I get it right this time. It's just really nice to get it absolutely perfect, seated properly. The connectors are extremely robust. As you can see, they have 2 pins for every socket terminal. So it just means that you can put loads of force on the little plastic lever, which has got a little spring behind it, and not worry about breaking the PCB or breaking the connector itself. I've used these orange, this one and that one's out as well. That's great. Kind of predicted that, so I can go back, just use my finger to shunt it back into the right position. There it goes. Oh, yeah. I can wiggle it around a little bit with my finger underneath to try and get it to seat properly. Let's check this one as well. Yeah, so I used a lot of these orange connectors and the bigger ones as well, but particularly these little orange ones are so useful, and it's been such a hardship using other types of connectors like screw connectors. Forget about it. An absolute disaster compared to these things. So spin it over, have a look. So that one's quite well seated at that end. This one, not that great. That one, no, not very good. That one, not very good. This one, pretty terrible. That one looks good. That one's terrible. That one's not very good. So there's a bit of work here to be done to get them to seat properly. Look at that one, that's just like miles out. So you can see that it's got to be moved to the left hand side a little bit. Oh, there we are. Just felt a sudden shift there. I'm just going to keep on going around here, getting them to seat right until they're absolutely perfect. Yeah, that looks good, this one. Yeah, this one's clipped. Yeah, hard. Oh, that's moved. I can feel it moved with my finger underneath. This one's out. Yeah, feels good. That looks better. I think this is the last one. Yeah. the ends now are perfect, except for this one slightly out. Let's keep that a little bit more. There it goes. I can feel it, that moved. Yep, that's good. And then the middle's good. Yes, there we go. So I can now tentatively try to solder the middles. Just keep checking it. As I said, I want it to be absolutely spot on. Next step is to solder in all these connectors here. There's a ground connector, 8 ways of ground. We've got another one here. Just can't have too many ground connections, it's really useful. So I'm going to go around the whole board, putting all these in. I'm going to solder them in individually to make sure that they're all nicely seated. And then look at what to do next. So we've got all the connectors that we want wired in now. I've left a few gaps. There's also this main 12 volt in connector here. Only because I can't find it. It's in one of the boxes somewhere. I'll find it later. But I'm going to put in a few headers here for the GPS daughter board. So the daughter board is another PCB, and it houses 2 GPS units from U-Blocks, Series 9, and that will give us heading by communicating between one and the other. That's right. Quite handy to have heading. So this is how this goes together. So the daughter board just plugs in, and there's some bolt holes there in case we want to secure it down. And then this little connector here goes here, and that handles the serial 3.3 volt and ground. Not sure what the 4th connection is for. Don't know. There we go. Okay, we've pretty much finished everything, and we're ready to plug in the MCU. Before we do that, there's a couple of jumpers that need to be removed here, notably SB57 and SB31. I think at the moment they enable the Ethernet to work, and we want to allow them to use PA1 and PA7 instead. So make a mental note to do that. I'm not going to do that right now. I found the 3 volt in connector, so I'm just going to demonstrate, test it anyway, see if it works or not. Make sure I get it in the right way around. Yeah. Quite easy to get the pins offset, so make sure that pins go in as they should do. Just gently push this in. There she goes. Nice. Keep you requiring force. So let's test the onboard LEDs and the beeper. So I've preloaded some code to do that. So when you connect this, it should go beep and flash load LEDs. There she goes. And over. There we are. LEDs flashing. So the other thing that I've tested, not on the video, but I've tested these 2 regulators by connecting 12 volts to here, just for the meter test that I've got 3 volts here, 3.3 volts there, and that's about it really. The rest of it be tested as it's actually installing in a robot, a proper robot.